Welcome to Khetz Tutorials, and in this video, I'll be covering question 19 from A exercises in James Stewart calculus. So this is a question. We are asked to solve the inequality and show the solution on a number line. Okay. So now there's a rule that says that you can add or subtract the values on either side of your operation. So that applies to equal signs as well. So if you have 1 plus x equals, let's say 5, to find a solution for this, one way to interpret this is that you're moving 1 to this side. Another way would be to say that you are subtracting that 1. So to remove it, it would be 1 minus that. And on this side, you do the same thing, 1 minus whatever value that you have. So let's do it in both ways. So this is x plus 1 equals 5. If I move the 1, goes to that side, and then I'll have 5 minus 1, which is 4, and that is my answer. So now you can add or subtract values on either side of your operator. And the same applies for an equal sign. So if you have x plus 1 equals 5, to remove that 1, you can subtract a 1 on each side. This is one way to interpret this, or just basically move that 1 over to this side. So it's 5 minus 1, and the answer is 4. This is another way as well. You now have x plus 0, which is just x, and 4. So that's exactly what we're going to do here. We're going to use this approach to solve this inequality. So if we start here, we have a minus 5 here, and we ideally want to isolate the term that has a variable, which is x in our case. And to do that, to eliminate this 5, we'll basically add 5 everywhere. So we're going to add 5 there, 5 there, and 5 there as well. So the next step will be us doing this, and this is if you want to show every single step. You can skip this step where you basically show these additions and just add it everywhere. But if you still want to do this, that's perfectly fine. So now here I have 5 minus 1, which is 4, and here I have minus 5 plus 5, which is 0. You just have 2x. Here 7 plus 5 is 12. And now this is what we have. Once again, even though we do have two operators, you can still divide everything. So dividing everything by 2 so that we eliminate the 2 next to the x, we now have 2 less than x less than 6, which basically means that to solve this inequality, we need answers or numbers which are between 2 and 6 not included. On a number line that looks like this, we're going to indicate that we have a 2 there and a 6 there. This doesn't have to be to scale, don't worry about that. And you're going to have an open circle there, open circle, and just connect these two. The reason that we have an open circle is because 2 and 6 do not satisfy this inequality, but anything between them does. And just to check that, let's pick 3. If we pick 3, which is indeed between 2 and 6, substitute it in there. You're going to have 6 there, then 6 minus 5 is 1. So 1 is indeed between minus 1 and 7. If you choose 2, then you're going to have 4 minus 5, which is minus 1, and minus 1 is not in between minus 1 and 7. So that's why I said 2 and 6 do not satisfy this inequality. But if you try any number which is between 2 and 6, and that should give you, or that should satisfy this. So our answer is 2 less x less 6.